In this lesson, you'll learn the characteristics and the properties of plane geometric figures. The characteristics of these figures: they have to be flat or two-dimensional. If you have a post-it, this is a square, this is a plane figure, but it's a flat figure. It's 2D or two-dimensional. Whereas if you have a stack of post-its, it's popped up, it's 3D, and it's no longer flat. These figures have to be closed. These three examples, only one of the examples is closed. You can see here there's an opening in this figure. It's not a plane figure. This one here has an opening. That is not a plane geometric figure. But this one, the square, has all sides closed, so that would be a plane geometric figure. These can have straight lines or curved lines. If we look at a triangle, has straight lines, a circle has curved lines, or it can have both. And it has to appear on one plane. Going back to the post-it, it has to appear on one plane as opposed to appearing on multiple planes. The properties we're going to want to know for these plane figures: we want to know the number of sides, the number of angles, vertices, and that will tell us the name of the shape. The sides. A straight line that makes part of the shape is known as a side. So if we look at the straight part of the figure, that's the side. So in this figure you have 1, 2, 3, 4. 1, 2, 3, 4 sides. This one also has 4. 1, 2, 3, 4 sides. This one also has 4. This shape has 3 sides. You can see here 1, 2, 3 sides. And if you look at the next figure, there again a straight line. There are 0 straight lines on this circle, so that has 0 sides. This figure has 1, 2, 3, 4, 5, 6, 7, 8 sides. If we look at a real life example, the piece of paper, we would have 1, 2, 3, 4 sides on that piece of paper. The second property, angles. These plane geometric figures have angles. These shapes, I've already written how many angles they have, and I've drawn in the angles. So let's take a look at what is an angle. It's where two sides meet. So these two sides meet to form an angle. If we look at this example, we have these two sides meet here, 1. These two sides meet here, 2, 3. There are 3 angles in this shape. There are 1, 2, 3, 4 angles in this shape. Remember, our circle had 0 sides, and if 2 sides have to meet, well, that's impossible for a circle, so there are 0 angles. This shape has 4 angles, 1, 2, 3, 4. This shape has 3. And this shape has 5 angles on the shape. Now, one particular angle I want you to remember is a right angle. A right angle has a square corner. So I've drawn 3 right angles. This right angle doesn't always have to be perfectly sitting up, but it does have to be a perfectly square corner. I like to use a piece of paper to be able to tell, because I know that this post-it has a perfectly square corner, and if you slide it in there, you can tell that is a perfectly square corner. If I slide it into this second shape, that's a perfectly square corner. It's just flipped. And this one's kind of on its side. If I slide it into the angle, that's a perfectly square corner. So that would also be a right angle. Now notice I'm marking my right angle with a little box. That will tell me it has a square corner. Any of these shapes, let's see if these have square corners or right angles. Well, I'm going to use my paper, slide it in. I see one here. Let's see, this one, no, that doesn't fit. That does not fit. keep trying. Those do not have any. I can tell these are bigger. These don't look square to me, but I'll try it anyway. That one's not quite square. Not quite square. You can see it has leftover. This one's almost, but not quite. You can see the white right there. We know there are 0 angles here. This one looks like it might have a square corner. Oh, there's a square corner here. Square corner here. And both of these are also square corners. So you want to mark your right angles with a little box. Now if we look at a real life example, if we look at this house, I can find a shape somewhere in this house. If I were to look at the door, so let's say I have the door. This door, let's see how many angles it has. 1, oops, 2, 3, 4. And I know that from my memory from here, these are 4 square corners, or 4 right angles. The third property are vertices. Now the word vertices, that's the plural form of the word, but if you were only talking about one, or the singular, you would say vertex. Another word for a vertex is a corner. Here are some shapes. I like to mark my vertices with points, with little dots, so that I can really bring out and show that it's a vertex. Now if we look to see what is a vertex, it's where 2 sides meet to form an angle. So I know that this is a side, this is a side. I remember here's a square angle, so the vertex is right on the corner. So going to the circle, this has 0 sides, 0 angles, so it must have 0 vertices. This one has 1, 2, 3, 4 vertices. This has 3, 4. This one has 1, 2, 3, 4, 5, 6 vertices. If I were to look at a real life example, like the top of your desk, the top of my desk has nice square corners. The top of your desk might have the more rounded corners, so it might not count, but the top of my desk has nice square or right angles, and you can tell that there are 4 vertices on that shape in real life. Now that we know the properties of these shapes, or these plane geometric figures, we can name them. The first one is a circle. We know a circle has 0 of everything. 0 angles, 0 sides, and 0 vertices. This one is called a triangle. The prefix tri means 3. So it has 3 angles, 3 vertices, and 3 sides. Moving along, these two, the brown and the orange shape, along with these brown and orange shapes, these 4 are called parallelograms because opposite sides are parallel. Opposite sides are parallel. But these two have a specific name. This one, because all 4 sides are perfectly equal, just like our post-it, all 4 sides are perfectly equal if you were to measure it. And so we call it a square. It also has 4 right angles in a square. This rectangle is kind of like a square stretched out. And it also has 4 right angles, which we call that a rectangle. And going on to these 2 parallelograms, this one, because it's kind of like a rectangle slanted, this one, same thing, kind of like a square slanted. This one, a parallelogram, both or opposite sides are parallel, and rhombus, because just like the square, it has all 4 sides that are equal along with being parallel. In the middle here we have a pentagon, has 5, penta means 5, hexagon, hexa, the prefix means 6, heptagon, meaning 7, octagon, meaning 8, nonagon, meaning 9, and decagon, meaning 10. Let's double check if I really fit in 10 sides. 1, 2, let's mark them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. A 10-sided figure is a decagon. Now, most of these shapes, except for the circle, because there are no straight sides, but all of the shapes except for the circle are called polygons. A polygon is a closed plane figure made of line segments that are joined together. So instead of just calling these plane geometric figures, you can also call them polygons, except of course our circle.